Well, hello, good evening. Welcome to SpaceOddities. Thank you for joining us on this Tuesday. Hope everybody's well out there. I see we've got a few in. Gerard can't be with us tonight. Derek, good evening. And that's about all in the chat. So if you're around, say hello in the chat. We'd like to know who's here. So first things first, I'm afraid we won't be able to bring you the astronomy and music quiz this evening, because Ian, who was doing the quiz, is ill. So I'm afraid we're going to have to postpone that till a future date. We'll let you know when, obviously. So I am joined tonight by what have sadly become some familiar faces. Michael's here, and Roger's here, and Lou is here. And how is everybody?
Fine, thank you. How are you?
Not too bad.
Good, good. And Lou, are you okay?
Oh.
Well, we'll take that as a yes.
Yep. No microphone, Lou.
No, we can't hear you, Lou. Okay, he'll sort
in
that.
In space, no one can hear you chat.
Absolutely. So instead of the quiz tonight, we've got some odds and ends to bring you, which we've had to put together rather quickly, unfortunately, because it's all a bit last moment. So I hope you'll bear with us. I hope you've all had a fantastic week. So I think the first thing we're going to do this evening, just do a bit of housekeeping. If you would like to support SpaceOddities, you can, of course, buy us a coffee, as always. So you will see the QR code on the screen, but a link will have just appeared in the chat for that. So click the link and you can buy us a coffee if you would like to, of course. Any money received goes towards keeping the channel running, so we're very grateful for your support. You can also support us by clicking the super chat icon underneath the chat window, the one with the $sign on it. And, you know, we'd prefer lots of dollars, obviously, but in lieu of that, then any money that you would like to directly donate to us rather than buying us a coffee, you can do that by clicking that icon. And as I said, all the money received goes towards keeping the channel running, which is what we want. And I hope you do too. Of course, you can visit the SpaceOddities shop, where we have a selection of T-shirts and hoodies for your delectation and delight, and hopefully purchase. So you can click the link in the chat to go to the shop as well. So I think without more ado, what we're going to do later is we've got our Constellation of the Week that we started last week with Ursa Major. This week we're moving on to, I think, what is a lot of people's favorite constellation in the winter, that is Orion. So Michael's going to be telling us all about Orion, which is, as you know, a fascinating constellation. Before we do all that, we're going to go over to the news. So let me just sort myself out here, and we'll go over to the news. Not that many stories in the news this week, but some rather interesting ones, as I'm sure you will agree when you see this. It's a very funny story in the news tonight. So let me just put that where it needs to be. There we are. And let me just go here. And here we are. Okay, so the news for the 28th of Jan 25. Unfortunately, great sadness, we say farewell to Gaia, the European Space Agency's observatory, which has been mapping the Milky Way galaxy with exquisite precision since it was launched in 2013. It started operations in 2014. And it has catalogued well over 1 billion stars in the Milky Way. But before we do that, let's have a look at a little video about it, which will tell you a bit more.
This is our galaxy, as seen by our Gaia Space Telescope. But what does the Milky Way look like from the outside? No spacecraft can travel beyond our galaxy, so we can't take a selfie. But during its lifetime, Gaia made 3 trillion observations of 2 billion stars and other objects, giving us the best insight yet of what our home galaxy looks like. In this new animation based on Gaia Data, we can identify the Milky Way's central bar and its spiral arms. We now see the galaxy edge on and can identify its bulge and disk. Gaia shows that our galaxy's disk is warped and wobbles, possibly caused by a collision with another smaller galaxy. Moving further out, Gaia also studied other galaxies around the Milky Way, such as the Large and the Small Magellanic Clouds, and 40 other companions. Gaia revealed our galaxy's turbulent history by tracking the movements of streams of stars. Gaia gives a unique view of our Milky Way, scanning our galaxy from the inside out, building a more detailed map than ever before, fundamentally changing what we thought we knew about our home galaxy, where our sun is embedded among billions of stars. This is where we live. This is our home.
So this is what they were talking about in the video. This is obviously an artist's impression of our galaxy as seen from outside. And from the Gaia data, astronomers have established that our galaxy, rather than being flat like a pancake with the central bulge in the middle, does actually have a sort of a warp or a kink in it, which is very probably due to an earlier collision with another galaxy, although exactly when that happened, we're not sure at the moment. That may be revealed with further release of Gaia data. And talking of Gaia data, there have been 3 releases of data so far, and another one with the last bit of data that Gaia has gathered is going to be released mid next year. And then at the end of the decade, the whole set of data comprising all of the measurements that Gaia has made will be released. And it's very sad to lose Gaia. So why are we losing Gaia? Well, we're losing Gaia because of the fact that it relies on cold gas thrusters to keep it in position. And basically the gas has run out. So it can't be moved around and pointed anymore. And it took its last measurements on January the 15th. It's been a hell of a journey with Gaia and has led to many scientific discoveries. For example, discovery of new asteroids, exoplanets, and stellar streams. The revolution that the so-called thick disk of the Milky Way began forming an amazing 13 billion years ago. So that would be 800 million years after the Big Bang, and very soon after when we consider the formation of the Milky Way to have started. So the thick disk formed very soon after the Milky Way started forming. And that was a bit of a revelation because nobody knew when the thick disk of the Milky Way had formed, but nobody expected it to be that early in its history. As I said, the discovery of this warp in the Milky Way, the result of a past collision, the detection of starquakes, tiny motions on the surface of stars, and it has allowed us to understand the formation and evolution of the Milky Way a lot better. So we say goodbye to Gaia. We hope to be chatting to somebody involved with the Gaia project at the European Space Agency, or I think it's UCL, isn't it, Michael? The person? Yeah, UCL, University College London. We hope to have somebody on the show very soon to talk a little more about Gaia and its discoveries, because to develop a space telescope like this, which has such exquisite precision, is amazing. And what Gaia has been measuring for each star is its spectral type, therefore its temperature, its position, its size and its velocity, and where it's moving to. So by rewinding the trajectories of these stars, you can sort of look at the Milky Way as it used to be. And as I said, we hoped, I'm not an expert on Gaia, but we hope to have somebody who is to talk to you on the show very soon. So you've got that to look forward to. Also in the news, you may remember that we covered live the launch of the Blue Ghost mission to the moon, launched by a SpaceX Falcon 9. It contained 2 landers, the Blue Ghost lander and the Hakuto R Mission 2 lander. And just sort of give you a little bit of an update on Blue Ghost. Blue Ghost is still in Earth orbit. It's being checked out and prepared for its journey to the moon. It will arrive at the moon on around March the 2nd. So far, all systems are looking good. It's taken a few photos of the Earth, and this is one of them. This is the Earth as seen from Blue Ghost. The other rover, the Japanese Hakuto R mission from a company called iSpace in Japan, they also have all systems go. Hakuto R has actually left for the moon on its trajectory, but it's taking a long way to get to the moon, and it's not going to arrive until about May. So it's about 4 months that the journey is going to take for Hakuto R to get to the moon and land on it. Very exciting that we've got 2 landers going to the moon now. And here's was the actual deployment of Hakuto R M2 when it left the upper stage of the SpaceX Falcon 9.
High space resilience separation confirmed.
And there it goes sailing off into the distance, and a perfect deployment. And you have the other rover, the actual Blue Ghost, in the foreground there, and that was deployed a little bit later. But all systems go for both landers, so we're really looking forward to seeing these 2 rovers land, Blue Ghost on March the 2nd and Hakuto in May. And we will obviously keep you fully up to date with what's going on with those. Right, another story about China. China's been in the news again for all the wrong reasons. They've done it again. They've dropped a rocket onto a populated area. It's unbelievable they've done this again. This was the launch of a Long March 3B rocket from China. And it wasn't the actual rocket that fell on the populated area. It was the SRB, the solid rocket booster. In other words, one of those. That's what fell out of the sky. I've got a video here, not of the actual impact itself, but 2 people witnessing it. And you'll see what I mean in this video. Or not. Excuse me a moment, doesn't appear to be playing. There we are. So there you are. So that was the impact of the SRB not far from where these people were. Absolutely disgraceful behavior that China doesn't care about its own citizens and just drops rockets on them when it feels like it. And the thing is, Michael, you'll probably know this. They've got no excuse because they've actually built a spaceport on the coast.
Oh, yeah.
Yeah. And there's no excuse for launching it from inland now. Why they're doing it, I don't know, because they've got a brand new spaceport on the coast from which they can launch out over the sea. Yeah, so why are they still dropping rockets on their own citizens? Obviously, they don't care. Very, very bad. And things like this give space exploration a bad name. Yeah. Okay, let's move on. So the next story is that Curiosity has very excitedly, this is the Curiosity rover, of course, on Mars, it's found some ancient ponds. Now, Curiosity's been there since 2012, and what it's found is evidence of ice-free ancient ponds and lakes on the surface. And it's found small undulations like those seen in sandy lake beds on the Earth. So they would have been created by wind-driven water moving back and forth across the surface. And the only conclusion you can reach is that there would have been freestanding water on the surface of Mars, and the discovery suggests the ripples formed 3.7 billion years ago. But so we now know at least that point there was water on the surface of Mars. So really exciting discovery. Let me show you what they're talking about. So these are the images from the Curiosity rover, and they are extremely reminiscent of what we see on the Earth in ponds and lakes, with the wind blowing the water across the surface and making these markings. So really, really interesting stuff from Mars. Lou, have you got any thoughts about this? Have you seen this? Lou not there? No, is Lou not there?
There we go. Can you hear me now?
Yes, we can, Lou. Yes.
A little bit of a delay. Lots of echoes.
Yeah.
We have known. We have known for quite some time that the surface of Mars has lots of liquid water, especially the northern hemisphere, which tends to have lower, kind of a lowland. And so the question then was, what happened to the water? And we think we understand that. We launched native spacecraft to identify the erosion of Mars' atmosphere and how it some of the water, which are broken apart into hydrogen and oxygen. Hydrogen takes its light, stayed bonded to the surface materials. So we've known all this. The waves are interesting. The 3.7 billion year figure is consistent with our understanding of when Mars may have lost dynamo and water in the atmosphere really started to erode. So this is exciting news. And I think it correlates well with the other things we thought we knew about Mars. And we'll keep exploring.
Absolutely. So it said the 3.7 billion years is we already sort of knew that water could have existed at that time on Mars, yes?
I think so. However, since we know water exists in abundance on the surface, the question is, when did it leave, really? And probably we know that the primary driver of this atmospheric erosion velocity of its magnetic field. So all those pieces of information need to come together and support each other.
Sure. Right.
And then there's an echo when I speak. Oh. I've been used that before.
Okay.
Andy?
Yeah.
I think I've got it.
Okay. Well, there's not much I can do about that at the moment.
Can you hear me?
Yeah, I can hear you. Okay. Yeah.
You're very, you're echo.
Okay. Well, not to worry. There's not much we can do about it at the moment. Okay. So moving on, last story today concerns the discovery of a new asteroid. So what happened was that an amateur astronomer in Turkey spotted an asteroid moving through space at the start of January. Following the correct procedure, he submitted his findings to the Minor Planet Center at Cambridge's Harvard Smithsonian Center for Astrophysics, which is what you should do when you discover a body like this. And the asteroid actually passed within 150,000 miles of the Earth, so between the Earth and the Moon. Now, this is nothing particularly unusual because new asteroids, as we know, are discovered all the time. But there was more to this story than met the eye, because it turned out not to be an asteroid at all, even though it was given a catalogue number. Do you know what it was? Any guesses?
Spacecraft.
No.
It was the car.
It was it was Elon Musk's Tesla.
Wow.
Yeah. And it was reported as an asteroid. So you may remember, viewers, that this car was launched on the maiden flight of the Falcon Heavy rocket a few years ago. Can't remember how many years ago. But ever since, it's been in an elongated orbit that takes it from the orbit of the Earth.
Did you say Elon?
Yeah.
Okay.
Yeah. Elongated. Oh, sorry.
Please do keep that.
Don't give up your day job, Lou. So anyway, this is on an elliptical orbit, shall I say, that takes it to the orbit of the Earth and out near Mars, although it's never going to actually crash into Mars, luckily. It's the last we need, Tesla on Mars. So anyway, this was reported as an asteroid by the amateur astronomer in Turkey. So it wasn't. It was the Roadster, still going strong, obviously. And there is actually a website where you can go, and I think it's still active, that'll show you exactly where the Tesla Roadster is at any one time. Of course, it's not just a car flying through space driven by that dummy, and I'm not talking about Elon. It's actually attached to the upper stage of the Falcon rocket still.
How many miles on the clock?
Quite a lot, millions, I would think. But there we are. So I just thought I would show you that. So that's it for the news for today. There hasn't been much else of note in the news this week. Does anybody have any thoughts about Gaia? It's a sad loss to astronomy. So
I had a thought about it. When I heard Gaia, I started thinking about Hipparcos.
Yes, of course.
Another successful and yet sad story. The Hipparcos satellite, named after Hipparcos, who did some of the original cataloging of stellar positions 2,000 years ago or so. I believe it cataloged about 100,000 star positions to very high accuracy, and then maybe 1 million stars to somewhat less accuracy, not as productive as Gaia. But it died. It had one of its engines, its propulsion engines died. I forget exactly how that happened, but a successful mission, but gone too soon. So I'm wondering if we have anything else up there that can do this kind of high resolution, high spatial resolution characterization of stellar positions. I don't know.
Well, I was actually looking into this, and unfortunately, there is no plan to build a successor to Gaia at the moment, which is a real shame, because, out of the, as you Americans will say, the 100 or 200 billion stars in the Milky Way, and
Gaia. Did we say that? Oh, okay.
Well, I would prefer to say 200,000 million, of course, but if you like 200 billion. And Gaia's only measured a tiny fraction of them, so there is a lot of scope for making a much more extensive map of the Milky Way.
I wonder what the Astrophysics Decadal Survey says about that.
Yeah,
sometimes they're very 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 nicely focused on filling holes in the full spectrum of ways we can observe the universe. So perhaps there's something there.
Yeah. we'll have to wait and see. But obviously, it's a very, very important piece of work to map our own galaxy and understand its formation and history. Because if we can't do it for our own galaxy, what chance have we got with others? So the work that Gaia has done is obviously applicable to other galaxies, especially when we find strange things like the kink in the disk of the Milky Way. So yeah.
One of my jobs straight but as an undergraduate was as a junior research assistant at the University of Maryland. Seems like I made $1.75 an hour or something like this. Anyhow, I worked under the tutelage of Dr. Frank Kerr, who was at the time, I think you could say still is, a very famous radio astronomer.
Right.
And just a great guy. And the project they were looking at was to map the shape, structure and shape of the galaxy, our galaxy, using 21 centimeter hydrogen measurements that you can get in the radio frequency, of course.
Yeah.
And I don't think we detected anything like curvatures at the edge. So
no.
A while ago.
Yeah, it was a bit of a, mind you. I mean, the last couple of decades, we've seen a bit of a real transformation of our understanding of the Milky Way. A couple of decades ago, we didn't even know that the Milky Way is a barred spiral galaxy. We didn't know the bar was there. And I don't know about restaurant at the end of the universe, but I'm happy there's a bar at the center of the Milky Way.
Oh, yeah.
It's fantastic. So yeah, we've come a long way in understanding the Milky Way, but there's an awful long way to go yet. There's also, of course, been the discovery of a hole punched right through the Milky Way by something really massive a long time ago, and we don't know what that object is. Because of I can't remember how big the hole is, but it's big. And, the only thing that we would know about that would make a hole like that would be a black hole, because it's the only thing that would have the gravity to do it. So it may be that in the distant past, a black hole, sizable black hole, punched its way through the disk of the Milky Way. Interesting stuff.
You said the right phrase, a sizable black hole. A stellar mass black hole, I'm not sure you would notice.
No, exactly.
So the implication is, if I might stick my neck out a bit, that was not just a large, massive black hole, but was a core of another galaxy.
Oh, right.
Right. So how do you form supermassive black holes? Well, we see them at the centers of galaxies. I don't think we see them anywhere else.
I have another possibility.
Okay.
It could have been one of these elusive populations of intermediate mass black holes.
Elusive is the right word. We know of many of these.
No. Well, it depends how you define intermediate mass. Astronomers are working on the basis at the moment that it's between 100 solar masses and the lightest supermassive black holes. But the problem with that is that we don't know the lower mass limit for what we would call a supermassive black hole. So we are basically talking, between 100 solar masses and maybe 100,000 solar masses, somewhere in that.
Okay, so not huge.
No.
Although we talk a lot about the solar system formation and how chaotic it is. We don't talk often about how chaotic galaxy formation is, if we know.
Yeah, true.
But of course, there's evidence of the large and small Magellanic Clouds. They get ripped apart. Maybe it was part of that.
Maybe.
I don't know.
Or could it be that whatever punched a hole in the disk of the Milky Way was responsible for this kink that Gaia has discovered? Interesting. Time will tell, I guess. Okay.
Time and perhaps our audience will tell us. I'm sure they have some thoughts.
Anybody have any thoughts on that? Because, as Lou said, if it were a stellar mass black hole that had punched a hole in the disk, we wouldn't notice. It just doesn't have enough mass therefore gravity to do that. So a larger object, like Lou said, the core of another galaxy. But you know, the dwarf galaxies that I was going to say orbit the Milky Way, but as it's recently been discovered, they don't actually orbit the Milky Way. They're all moving in different directions and not heading into the Milky Way. It could have been, you know, the core of one of those. Or something bigger, like one of these legendary intermediate mass black holes, which we're pretty sure exist, because it doesn't make sense that we see black holes up to around 50 or 60 solar masses and then nothing until we get to supermassive black holes. There must be an intermediate population. That's fairly logical, but they are hard to detect. The heaviest mass black hole that we've found so far weighs in at, I think it's 147 solar masses, which is the result of a merger of two smaller black holes. So the idea is that you've got this hierarchy going from stellar mass black holes that merge together, and then that resulting black hole merges with another black hole, increases again, and then that merges with another one, up a hierarchy until you possibly get to supermassive black holes. The only problem with that is that you would have to have those black holes in an area where there were a big population of black holes, and whether there would be enough time for that to happen until you get to the supermassive black holes that we measure. Don't forget, we're seeing these in the very, very early universe. Whether there's enough time for that hierarchy to work its way through is debatable. But anyway, interesting stuff. Right there. Well, in time-honored tradition, we're going to move on to Roger next. But yeah, if you've got any thoughts about that, got any questions, observations, comments, anything you want to say to us, viewers, please put it in the chat. So we have coming up for you now the night sky guide from Roger and the gallery for the week. So I'm going to hand it over to Roger now. So what's been going on, Roger, or what is going on?
Well, we'll come to that. Don't a spoiler alert, do we?
No. No.
Okay, so here we go. From the end of January into the start of February. So we're just about to get to a new moon tomorrow. So any chance of getting out there and seeing anything might be advantageous, although I've got a reasonably clear spell for Thursday, so that's not too bad. So all being well there. So we've obviously got Orion, as we will be talking about more, dominating the southern horizon, and we've also got obviously the associating constellations of Auriga, Taurus, and Gemini, and we're getting through to Cancer and further over into Leo for the spring galaxy season, of course. And all's looking quite well at the moment. So no interference from the moon at the moment until later in the week. But as many people are aware, we've got this, what we call a planetary parade, which according to my local TV station says that we were also able to see Mercury, although you would have to be very diligent to spot it shortly after sunset. But going from right to left, we then got Saturn, Venus, Neptune with a telescope or a very good pair of binoculars, and then to Uranus, Jupiter, and Mars. So should be quite good. And if there is an opportunity to get a very wide panorama, I want to see them in the gallery for next week. Okay, so we've got a very brief show tonight, and we've only got 2 entries for the gallery. So I'll try and elaborate as much as possible. We've got a very nice picture from Jerry of the Rosette Nebula, which he says has got some animal shapes inside, and his usual setup. And this is what he's managed to produce.
Oh, that's nice.
Oh,
that's
beautiful.
a very
wow.
Yeah. Lots of dark cloud structure there as well.
Yeah, that's very good.
obviously it depends on which way you orientate the camera, but it's still the Rosette Nebula.
Okay.
Yeah, very good. Of course, if you generally try and locate it, then you can usually just find the central cluster of stars. Then you might just about see a glimmer of some of the structure otherwise. But very well done, Jerry. And then we've got another nice astro landscape from Lee, which he's got from the Corey, and the 12th of January, so the night before full moon. And he's obviously did a blend of sky and the ground here, and look at that.
Oh, that's lovely. Oh, lovely.
And obviously, and you can see the glow and glare of the moon there shining away to make it more like a daylight view.
Yeah. And there's Orion. Bit of a theme.
And there is an Orion image there indeed, with a distinct view of the nebula there.
Yes, I can see it now.
So very well done.
That's another winner. Beautiful shot.
He does take a nice landscape.
Yeah, very atmospheric shot. Yeah, lovely. Thank you so much.
Lucky to have a local location for him to just quickly get out there and get on with it.
Yeah, very picturesque.
Yes.
Yes. Yeah. And that is it from me. Wow. That was almost an abridged version.
Yeah. Yes. Please, viewers, if you would like to send your images to our weekly gallery, please attach them to an email. Send them to gallery@spaceoddities.space. One image per email, please. And if you could send them as attachments rather than pasting the image into the email, it will make things a lot better for us, a lot easier for us. And there you are. And as we keep saying, you don't have to use expensive equipment. Just get out there with a camera, and anything you take that you think people would like to see, send it into us at SpaceOddities at gallery@spaceoddities.space. And thank you very much. Let's see your images, because we love them. We look forward to them. And we've only had 2 this week, so thank you to Jerry and Lee. But I'm sure there are lots of others out there. So look through your photos, and we promise we've never said anything bad about the images. We love all the images that you send us, and so please do keep those images coming in. Of course, once you do send your images in, and we feature them here on a Tuesday night, they do appear in your own little gallery on the Space Oddities website, which I'm just going to show you, just to show you what people are doing. This is what we're going to look at here, and there we are. So this is the gallery, and as you can see, everybody here has got their own gallery. So if we take Jerry's, for example, all the images are there. You can click on any of these images to see it much bigger and with all of the details, and then there's a full screen icon here where you can enlarge it to see it in all of its glory. So this is what you get free. We feature your photos on Space Oddities in the gallery here, and it's worth pointing out that the copyright, if you're worried about copyright, you retain full copyright. There's no problem with copyright. It's all yours. So there we are. While we're here, may I just put in another word for the Capcom magazine. Michael works very hard producing this magazine every 2 months. It's a magazine about space flight and rocketry. Here are some of the covers of the magazines of time gone by, and it's free, and you can get this free from Space Oddities. It arrives in your inbox as a PDF file. And it's a jolly good magazine. And Michael has been producing this for many years now. How many years, Michael?
Oh, more than 30.
More than 30. Michael's been doing this for 30 years.
I started in the early 90s. So
yeah.
So
he knows what he's doing, and or should do by now. So this is, as I said, this comes out every 2 months. It's free. If you want to learn about space flight and rocketry, if that's your bag, then subscribe to the magazine. And all we need you to do is to send an email to capcom@spaceoddities.space. That's Capcom, as you can see written there on the covers, @spaceoddities.space. And if you could just put the word subscribe as the subject of the email, you don't need to put anything else. Send that to us and you will be put on the mailing list for this wonderful free magazine that Michael works so hard to produce. So show Michael some love, because God knows he needs it. And there we are. So that's Capcom magazine. So and do have a look around the rest of the website while you're there. We've got some other stuff there which we hope you'll enjoy, and we've got more stuff coming on the website soon. So that's just a quick plug for the gallery and for Capcom. So there we are. So Dave says you missed me off the gallery again, Roger. Dave, I don't know. I did send you an email. I think you're still sending your.
He's sending it to the old SpaceOddities email, because I had to look through and it wasn't coming through to the.
No,
it's the one that we had when we had it all on the Gmail.
On the Gmail. Yeah, I did send you an email, Dave, telling you the reason we're not showing them, that you're sending it to the old address. So if you just resend your images to gallery@spaceoddities.space, we will show them on the show and put them in the gallery. I have actually, just to show you, Dave. Let's just go back to this, just to prove that we're not neglecting you, Dave, which of course we would never do. Yeah, I know. So let's just go back to that. And if we go to the gallery, Dave, you can see you have got your Witch's Broom Nebula image in the gallery. I did find that in the old Gmail address, and I have posted it on the website. So you do have your own gallery. So please, if you just send it in the future to gallery@spaceoddities.space, then it will be featured here and on the website. So there you are. Okay, moving on then. We're going to talk about this week's Constellation of the Week now. We did Ursa Major last week as a new feature, a new weekly feature on the show. And Michael, that is going to tell us this week about Orion.
I am.
If you like our Constellation of the Week, viewers, then tell us so in the chat. So, you know, and if you've got any suggestions for a Constellation of the Week that you would like to see us feature here on a Tuesday, then tell us which constellation you think we should be having a look at, because people do have their own favorite constellations. I think Michael, Roger, and myself are agreed that Orion is our favorite, but you may have another one. I kind of like Cassiopeia as well. Yeah, and so there we are. So Michael, I'm going to hand it over to you now.
Okay.
And
I'm just going to share my screen.
Okay.
Bear with me a second. And I'll get there up properly. Okay, can you see that?
I can't see the slideshow. I can only see the PowerPoint window.
You can only see the...
I can only see the PowerPoint slide window, not the slideshow. You need to share the slideshow.
Why is that there?
Right, go to slideshow along the top there, and then go to start from the beginning.
Yeah.
What left-hand one? The left-hand one.
Left.
Oh, it's like Bernie the Bolt on the golden shot here.
Yeah, Bernie the Bolt.
So, can you see
that?
that?
Aston.
No.
No. Oh. Still the right.
Why is that not working then?
That's a good question.
From the beginning.
Yeah, this is from the beginning. I'm sharing my... Oh,
you need to click the... No.
Just bear with.
Oh, dear. You can't get the staff, you know.
No, I know.
You really can't. It's just...
hopeless. It's hopeless.
You need to stop sharing this and share the slideshow window.
Share the slideshow in 1 minute.
Yeah, okay.
Do
bear with us, viewers.
A quick...
He's going through a difficult time in his life.
He's still recovering from his birthday.
Yeah, absolutely. Absolutely. Yeah.
It's only a week ago.
Yeah. Okay, you need to stop sharing that.
How's that then?
Ooh,
That looks more likely. Yeah.
There we go.
that's it. Yay.
Sorry about that. Sorry about that, folks. Right. This is a quick overview of the constellation of Orion. I think what, as Andy said, it's quite a favourite amongst many astronomers, if not all of them. So yeah, just bear with me a second. I just want to do something else. Okay. So this is a screenshot of Stellarium, showing the Orion constellation in its location in the southern sky, as seen from the United Kingdom. This is how it was a few nights ago, with Jupiter in Taurus there, and Uranus as well. So I'm just going to go through these slides and we'll chat about the constellation. So
Okay.
here we go. So this is a standard star map of Orion. It's a lot easier to view a paper star map with black on white background, black stars on a white background. So many astronomers use this when observing this kind of map when they're observing. You can see the outline of the Orion constellation there. Can you see my cursor at all?
Yeah.
Okay. You can see the outline of the constellation there, and the actual official boundary of Orion marked with the dotted line, and the outside is grayed out with neighbouring constellations. Okay, and I'll just go through some main features of Orion. This is how the ancients looked at the sky and worked out what these constellations mean, or what they look like. And Orion was, they thought Orion was depicting Orion the Hunter from Greek mythology. So that's how it's not really easy to pick out the stars on that picture, but this is quite an ancient drawing of of Orion the Hunter. But in Stellarium, again, on the right-hand side here, you can see a lot easier why they thought that this group of stars looked like Orion the Hunter. Betelgeuse, for instance, on Orion's right shoulder, Bellatrix on Orion's left shoulder, and Rigel on Orion's left foot. The right knee, where he's kneeling down there, is the star Saiph, and they're all very bright stars. I'll go through them in a little bit more detail in a bit. But I'd like to point out one thing is, many of you know that astronomers use the Greek alphabet to designate stars in accordance with their brightness. Alpha being the brightest, beta second brightest, and so on. In the case of Orion, that's not correct, because Alpha Orionis is Betelgeuse on the top right shoulder, but Betelgeuse is actually dimmer than Rigel, and but Rigel is Beta Orionis. It may be because Betelgeuse is a variable star, and it could have been brightened up a lot brighter than Rigel in the past. So
interesting.
Yeah. Just another little thing about the sizes of these stars. This particular slide is very descriptive, because look down at the bottom of the screen. The sun is so tiny compared with Betelgeuse. It's just amazing how big Betelgeuse is. So Betelgeuse, although it's very bright, it's dimmer than Rigel, but it's a lot bigger than Rigel in actual size. So it's one of those things in astronomy where there's quite a lot of things that you don't really expect from the observation, so you look at things in a deeper aspect of them. And Aldebaran is there, the alpha star of Taurus, as a
comparison.
Comparison, that's the word. Okay, so I just want to go through a few stars of Orion. This is a very nice image that I've borrowed from the internet. I like it because it shows all of the stars and all of the, or a lot of the nebulosity that surrounds Orion. And you can see the different colours of the stars as well. There's Betelgeuse on the top right under the Orion's arm and so on. Rigel down there. So, and then Bellatrix and the Saiph I mentioned earlier. The belt stars, as they're known, as 3 stars of Alnitak, Alnilam, and Mintaka form the belt stars. Again, quite bright stars and very interesting to view in the night sky. You can see, as I said, you can see quite a lot of nebulosity there, and I'm going to go through some of that in a minute. So we'll just carry on from there. So, but this again, this is drawing the constellation. So showing which stars are the main constellation stars there, and then you also got this particular way. Like this is the main way of drawing the constellation of Orion, lining up the stars like that. Orion does extend out to the right or to the west, I think, with the sometimes depicted as Orion's shield, if you like. So it does extend across there, but that's the main stars. So let's go through some of these features and zoom in and see what we've got. Okay. First of all, we've got M42, or the Orion Nebula. And you can see that you can actually see the Orion Nebula with the naked eye on a good dark night. And it's an amazing sight just with the naked eye. But look at it through binoculars and a small telescope, you realise there's a lot going on there. A gaseous star forming region. And this is an amazing picture of that particular region as well. So, but within the M42, number 42 in the Messier catalogue, you have another feature. So we can zoom into M42 itself, and if you look at this central region here, we have a series of 4 stars, which is known to astronomers as the Trapezium. Trapezium is a lovely sight in small telescopes. It's been a long time since I've seen it myself, but I do remember it being a lovely sight in a telescope. If you can do that, that's a sight worth looking at. Okay, so back to the main Orion picture again. Another very famous nebula we're coming to now is this one on the left star of Orion's belt, which is the Horsehead Nebula. As you can see, it's a dusty region in the shape of a horse's head. That's how it appears in the night sky from the UK. But of course, many photos online and in books see it like this. So that's just tells you it just looks like a horse's head. It's amazing, really. Yeah. And next to the Horse's Head Nebula, you have this area at the top of the image, which is known as the Flame Nebula, another gaseous star-forming region. So zoom out, and you will see that there is another gas cloud in a massive arc on the left-hand side of Orion. And this is known as Barnards Loop, named after E. Barnard, who photographed it in 1846, I believe. But it was actually discovered by Herschel in the late 1700s originally. And I've just put a nice enlarged image of Barnard's Loop here. Lovely red nebulosity there in that cloud. So that's just another interesting feature of Orion. And I think that is it. So just a quick overview of some of the main points of Orion.
Great, thank you very much indeed. So yes,
if you want some other photographs, I have got some of the Orion images to show if you would be interested.
absolutely. Go for it.
All right then. Okay. So I've got a few. Right. Let me just. Right, let's share that one.
Worth pointing out that there are lots of other interesting deep sky objects in Orion, obviously, apart from
Yeah.
Right. Okay. Right.
That was just a taster.
just a taster. Yes. And don't forget, viewers, if you have a constellation that you would like us to feature in Constellation of the Week, then please put it in the chat, and we will certainly have a look at it. So there we are. So just having a look through the chat, any comments here that we haven't pointed out? Kenneth, in slightly colder climes than where I am at the moment, says getting all lovely aurora images now, not high due to KP. It's only 3, but strong negative. So beautiful between the clouds. So lovely. Glad you're seeing some aurora. Everybody in the whole world seems to be seeing aurora except me. I've never seen one in my life.
Yeah.
Although
there's a ship in Norway at the moment showing lots of aurora.
I know. And the images are quite lovely.
Yes.
So there we are.
Right.
Mike Beer says, thanks, Michael, my favorite constellation. It can't be the Mike Beer who's a friend of mine, surely. Is that you, Mike? Probably not. So I have an old friend called Mike Beer. Yeah, so there we are. So we'll bring you another constellation of the week next week. Not quite sure which, but we will do one. So going to move on now. And Roger, are you ready with yours?
I think so. Let me just try and get this damn thing to work. Anything?
No. Oh, yes. Hang on. I need to put it in the stream. Hang on.
Yes.
In the stream. There we are.
Nice.
Right. So we've got Horsehead there and the flame as well. Yeah. So all well and good.
Is that an old flame?
So on attack there, looking very spiky, right next to the flame there.
Is that the old flame nebula?
Well, how many are there?
The old flame. Oh, sorry.
Oh dear.
Oh, sorry.
Right.
You are romantic. Wow.
And got the Running Man over on the left-hand side there.
Yeah.
And you can see all the gas and stuff all coming out around it as well. It's almost as if it's almost like liquid nitrogen coming out of a container, spilling out over.
Yeah, definitely. It's
right.
Beautiful. Look. And these are all your images, I presume.
Yeah, these are all mine from deepest, darkest Sparkford. We've got a bit of Barnards Loop over on the left, and we've got M78 in the center of the frame, of which the next picture will be a more detailed close-up.
I presume that Barnards Loop is a supernova remnant, is it?
Possibly.
Yeah.
I'm not sure.
I think what else it would be. Anybody know out there?
I was watching something today about the Barnards Loop, and they were saying it might be something different, but I can't remember what it is.
Hmm.
All right.
So I'll have a look at that.
Yeah.
Yeah. So here's a closer view of M78.
Oh, beautiful.
See
That is lovely.
Get the structure there. And my last penultimate one, we've got the Witch Head. It's not a very good one, but it's reflecting the light from Rigel there.
Oh, right.
And if you look at it directly, it's upside down, so you have to rotate it about 180 degrees to be able to see it properly.
Wow.
So there we go. And then I've also got, bear with me, a hydrogen alpha picture of the Force Head in black and white, because I haven't had enough data. So share screen. Share.
And now is the time to get out and observe Orion, because once the spring starts beginning, it's going to sink further into the west each year.
Yes.
We're going to lose it.
Right.
So,
Okay, here we are. Can you see that one?
1 second. No, nothing happening here at all.
Oh. Okay.
Okay.
Oh, hang on.
What?
Here it is.
Ooh.
Yes. There we are.
That's nice.
Now that's just a black and white image, which is a hydrogen alpha image. So I've obviously still got the sulfur and the oxygen to assemble, but weather has not been very appreciative of getting these images. So one day I will get it.
That's remarkable. That's
and that's a good image in its own right, isn't it?
Yeah, isn't it? I mean, that framed would be fantastic.
Yeah,
I do actually have an aluminium print of it, so it does look. I do think it looks quite stunning.
Yeah, that's something I would have on my wall.
Yeah,
along with my Thunderbirds posters. No, I haven't really got Thunderbirds posters.
All right. Okay, I shall.
Go on,
sharing.
No, the poster I'm looking up at the moment actually is the County Mayo Dark Sky Park poster.
Oh, right. It's not Marilyn Monroe then.
And to the right of that, I've got one of the NASA solar system posters.
Okay.
There we are.
Yeah.
Thank you for those, Roger. Very good images.
That's all right.
As always. Okay, now next week on Space Oddities, not next Tuesday live stream, but next Tuesday afternoon, just to give it another plug, we are organizing a very, very special event in conjunction with the Polaris project, which, as you may know, has flown 2 private space missions into space, Inspiration 4 and Polaris Dawn. And we are delighted to get together with 2 of the astronauts, Anna Menon and Sarah Gillis, and they are going to be live on Space Oddities talking to 260 children in 4 schools in Yorkshire. And we're getting them together with the children so they can ask their questions. And the whole aim of the event is to show children that they can literally reach for the stars in their lives, that they can be anything they want to be. And we want to inspire them, showing them the success that the 2 ladies have had in space. And that's what we've got planned. We've been working on this with the Polaris project for 6 months, and it's all coming to a head next Tuesday afternoon at 2 p.m. UK time here on Space Oddities, and available obviously on the channel after that. One of the notable events that happened on that space mission was that Sarah Gillis, one of the astronauts, is a violinist as well. And she gave a violin recital from space with orchestras participating live all around the world, mainly of young people. And it was a fantastic event. And just to move towards finishing off this evening, thought you might, if you haven't seen it, thought you might like to see this video, because we're hoping that the kids are going to ask some questions about it. about her amazing violin playing in space. So this is just live from the Polaris Dawn spacecraft in Earth orbit, with youth orchestras around the world taking part live as well. So here is Sarah Gillis and her amazing recital.
Three, two, one.
Welcome aboard the Dragon spacecraft. I'm Sarah Gillis, one of the Polaris Dawn crew members. As we travel around our beautiful planet Earth on this 5-day mission, we wanted to share this special music moment with you. Bringing together global talent, this performance symbolizes unity and hope, highlighting the resilience and potential of children everywhere. Here is Ray's theme by John Williams, brought to you from the stars.
So there we are. So that was Sarah Gillis and her amazing violin performance from Earth orbit, and a truly international event. And it just goes to show that the exploration of space is about international cooperation. And I don't think anything like that has ever been done before, unless anybody knows different, but a unique event. So we will be featuring Sarah and her colleague Anna Menon from the Polaris project in our special live event from 4 schools in Yorkshire, and we hope you can watch. It's at 2 p.m. in the afternoon UK next Tuesday, the 4th of February. We hope you can drop in, but obviously if you're working or whatever, you can't. So let's hope it all goes well, and we are very grateful to the Polaris project for getting involved in this project, and we're going to be sending all of the children involved some SpaceOddities goodies, and also the Polaris project will be sending the children some presents as well. So we're really looking forward to this event, and we hope you can support us by just watching it. Really, it would really help us. It will be available on the channel after the recording. It will last for 1 hour between 2 and 3 UK time. That's when all the children go home, of course, so it can't last longer than that. And we hope you'll watch the video when it's on the channel. And if all goes well, we'll play some clips from it on next Tuesday's live stream. So I think that just about wraps things up for this evening. We'd like to thank everybody for watching, of course. And we hope that you have a fantastic week. And we will see you next Tuesday when we'll be bringing you more stuff. I'm not exactly sure what yet, but we will be back at 8 p.m. UK time here on SpaceOddities next Tuesday evening. So have a fantastic week, everybody. Take care of yourselves. From Michael and from Roger and from myself.
Good night.
We would just like to say, keep looking up. Get out, take some images, send them into gallery@spaceoddities.space, which is what we'd love you to do. And we hope to see you back here next Tuesday. So from all of us, take care and goodbye.